Hello friends, so today we are solving this problem, snakes and ladders. So we are given an n cross n integer matrix called board, where the cells are leveled from 1 to n square in the Boustrophedon style. So Boustrophedon style you can consider like this. So if this is our board, you can see here the numbering of these are starting from bottom. This cell, you can consider the coordinate of this cell. So we are starting with 1 2 3 4 5 6, and then from alternate node it is starting from right to left, so 7 8 9 10 11 12, and then next would be starting from here 13 14 15 16 like that. So this is the alternate way of increasing IDs, that is called this Boustrophedon style. So in that way those numbering of the cells is done. So we have to start from square 1 of the board in each move, starting from the square cut to the following. So see here what we are doing is we can start from this node. Okay, now what is happening, a dice, you guys must know that when we throw a dice there are 6 possibilities, right, in a dice throw. So 1 to 6 numbers are there. Okay, so if we throw a dice, you can see here like this. Okay, this is dice, right? It has 1 2 3 4 up to 6 surfaces are there, and all of them are starting from 1 to 6. Those values are there. So what will happen is here we can start from this first cell. Okay, now there are 2 possibilities. So these numbers are just the IDs of it. Okay, IDs of that cell, but these the actual value in the board would be having either -1 or some values, just like this. This is just for our explanation. You can see here, this is a one example of this board. So you can see most of them has -1, only few of them has like 35, this cell has 13, this cell has 15, like this. So what does it mean is most of you would know how to play that snake ladder game, right? So what is happening over here is we are starting from here. So there are 6 possibility. So whatever is the index of a cell, then we can move up to I plus 1 till. So let me write it down. So whenever a move happens, let's say we are at the ith cell. Okay, then we have 6 possibility. If we throw a dice, let's say at here, there could be either 1 2 3 or any one of them till 6, right? So that means we can make that many moves. Okay, so let's say if I equal to 1, then we can move to 2, we can move to 3, we can move to 4, like till the 8 7, right? Because 1 plus 6, so till the 7 we have the possibility. Okay, so if we are ahead here, we can come here, we can come here, any one of them, all the possibilities which are in this range. So that range is basically, if we are at ith node, then we can go to I plus 1 till I plus 6. Okay, so this would be our range, but because we have only up to n square, so this might go to out of boundaries. So that is why we have to take it here, I plus 6 and n square. So whoever is the minimum of these two, and the I plus 1, this would be the range where we can move. So any one of the cell which is falling in this range, we can move, right? So we are starting at 1, then it would be 2 to 7, right? So from 2 to 7, any edge we can move. So that is the one possibility when this value has -1. Okay, these are the IDs, but actual value would be either minus or -1 or some number. So in case if we have, let's say ith cell, if let's say ith cell has -1 value, then we have to pick any one of these values, 2 3 4 7. Okay, because this is the range of I plus 1 till minimum of I plus 6 and n square, right? In case of -1, if let's say this cell doesn't have -1, but let's say if it has 11, or let's say it has 9, so whenever there is a non-negative number, that means we have to move to the cell number 9. If let's say at here, if it was not -1, suppose there is in original board, if the value here is 9 at cell ID 1, that means it is either a ladder or a snake. So we can directly move to cell number 9 without worrying about this range. Okay, so let's say if this was a ladder, then ladder could looks like this. So this ladder would be directly permitting us to move to directly cell number 9. Okay, so this was the one possibility. Similarly, there could be snake as well, just like this. So let's say if this is if let's say this cell number 4 had value 7. Okay, so let's say it has value 7. In that case, what would happen? Whenever anybody who is reaching at this edge, at this cell number of, you can say cell number 4, the value had 7. That means if let's say it were either a snake or you can consider a ladder, and we can directly move to cell number 7, right? So this is the concept of this thing. Now what we have to do is we have to find that how to reach. This is like our last target cell, right? This is 6 by 6, so 36. This, the ID of this cell would be 36. So our target is we have to start from ID cell equal to 1, and with the help of either these 6 possibility moves or with the help of snake and ladder, we might have the snake and ladder values as well. With the help of those movements, we have to find such a way so that we can reach this target cell in minimum number of steps. This is what we have to do. Okay, for example, let's say take the example given in the question. Okay, so here we can see here starting from 1, in one move we reach at 2. Now after reaching at 2, we have taken only one move. Now we can directly come to 15. So we reached at 15. Now see at this 15 edge, this is we have the 6 possibility, right? We can move to 16 directly, we can in 17, 18, all those possibility, right? We have this one starting from I plus 1 to I plus 6 and n square minimum. So now you can see here from 15, no, from the 15 cell till the 15 we have taken only one move. Now we are at 15. Now in one step we can move to 17, and 17 has a snake, so we can directly come to 13, right? So now what will happen? So far we have taken only 2 steps, 1 to 2 and then 15 to 17, 2 step. Now from 17 has a snake, then we can directly come to 13. Now in one step we can come to 14. So till reaching the 14 we have taken 3 steps. Now from 14 we can directly come to cell number 35 because that's a ladder. Now from 35 to 36 another move. So total 4 moves are the minimum one which we can reach to the target. So same thing we have to achieve. Now next thing is how to do that. So to do that, what we will do is, first of all, because we have taken this array is a 2D board, right? So what we will do is, instead of making it 2D board, we can flatten it. Okay, how we can flatten it? Flatten means we can just make in a straight array. Okay, not like the one which is written in this way. We can flatten it. So what we will do is, this one will come here, 1, 2, 3, like these cell ID I am writing, not the actual value in the original. Like this we can do that. But while we were doing, initially we are moving from left to right, correct? Then next change it has to go from right to left. Okay, so we have to create this array. Let's say call it ARR. This array we have to create, which will give us all those value till 36. Okay, so how to do that, I'll show you in my code. So first of all we have to do this flatten array. Let's say we are done with this flatten array. Then what to do next after doing this flatten array? So after doing this flatten array, what we can do is we have to check that how we can reach to the target cell with the minimum moves, right? That is our target. Okay, so if you look at here, consider we are at any cell. Let's say we are at any cell, say I, then we have total 6 possibility. If it is I, if this cell has value equal to -1. Okay, if cell has value equal to -1, then we can move directly to I plus 1 till I plus 6. Okay, considering the fact that this I plus 6 should not go out of this box, right? So I plus 6, this is our basically the range. Okay, we are using this minimum only to keep away the any kind of outflowing of the coordinate, right? So that is why we are taking this minimum of current plus 6 and n square, because it should not go beyond 36. For that reason we are doing, right? So this would be our range, right, for any cell. That means we have total these 6 possibilities would be always there for us if we are at any ith one, correct? Just like in dice throw, we get all those possibilities. So if we, so in one step we can choose any one of these in this range. Okay, for I equal to 1 we had like 2 to 7, right? So we could reach to any one of those node I plus 1 till I plus 6. Now that would be counted as one step to reach all those possibilities. Though we will make one of them move, but we have to find which one would give us the minimum value, correct? Now what will happen once we reach to any one of those node, then we have to again have the similar 6 possibilities, just like this formula. Okay, so in this way what is happening, you can observe one thing, right? This is going the kind of a BFS manner, correct? So in the BFS manner, if we are doing this, we can find that how many this movement we are doing to reach the target. So what we will do is we can use here BFS way. Now how that would be applied BFS? So we know that BFS use a queue, right? So BFS use a queue. Same way we also can do. Let's say we are making a queue of size 6, correct? So why size 6? Because we have 6 possibilities, correct? So what we will do here is, like, we can consider this is our queue of 6 size. Okay, so in this queue what will happen, we would be pushing our value. So first of all we will push here 1, correct? We will push here 1 and then we will pop out. So when we will pop out, we will look for all those 6 values that it can move directly. Now remember one more thing, it is not only those 6 possibilities, but there could be some actual value also in case of snake or ladder. In case of snake and ladder, we can directly reach to that cell. For example, let's say there was a 18 here on this cell. So we can if it is a non-negative value 18 or whatever it is, if it is not -1, that means it is a either snake or ladder. So we can directly move to that or ladder. Like here we could have, if this was 18 value, then we could directly to this this ladder, okay, this cell, using ladder or snake. So we have to take care of snake and ladder as well, and the all 6 possibilities. So if it is -1, then we have to look all the 6 possibilities, but if it is a non-negative value, then it would be snake or ladder. So whatever value, we have to push that cell value, okay, whatever is there in this snake or ladder value, that would be the cell ID, we have to push that as well. So in this way, what we will do is, whenever we will pop out the values from the queue, we would be check that, hey, is this value, the item which we have just popped out from this queue, if this is equal to our n square, right? Our n square is the final destination there where we want to reach, right? So whenever we will pop out the values, we have to check that if I or whatever item we are taking out, if it is equal to n square, that means we have reached. But every time when we are doing this 6 possibility, or in case of snake and ladder only 1 possibility, we are pushing that value into this queue. And whenever we are popping out from the queue, once the size we have taken for a level, at that time we are making, let's say, 1 variable result. So we will keep on increasing that result after making the one move in the sense, if it is -1, then 6 possibilities, any okay, and if it is single one, then it would be only 1 move, right? So we will take the size of it, and that many times we will make a pop, and after doing that we will increase 1 time for this result, because we need the number of steps. So we know that using the BFS we can definitely find the closest distance. Okay, so that is why we are going in that way. Now let me show you my code whatever we have explained, same code I would be showing here. So first of all, what I'm doing, we have created one array, right? That flatten array, we are doing flat of it. So see here, I have created one boolean variable left to right. So initially we are starting from here, right? We are starting from here left to right. So what I have done is I have just make this left to right boolean variable true. Now we are starting for k equal to 1, right? Because at 0th node it is not given 0 value. IDs are starting from 1 only. But in the array we have to create n square plus 1 size, because 0 index would be always there. That is why I have created this array of n into n plus 1 size, because 0th node we have to ignore, right? 0th cell. Now what will happen here, you can see here, when we are traversing for I equal to n minus 1, you can see this guy, the last row is basically the n minus 1th rows, right? And then we are going from left to right. So for that reason, what I am doing, for I equal to n minus 1, I greater than 0, I minus means we are starting from the bottom row. And if it is left to right true, which we started with the true value, so if it is left to right equal to true, in that case we are checking from column 0 till last column, right? So we are making this air of k plus plus equal to board ij. Otherwise what we are doing, otherwise we are checking in this way, right? Then if it is then it would be right to left when this boolean variable is false, right? So once we are done from left to right, we are coming out of it, and see here, I every time I'm making it opposite of it, so that next time we would be on the alternate side of the row traversal. Okay, so we are making, next time we are making is false. So when we will come again here, this time we will go inside the else loop, and when we'll go inside else loop, in that case we would be basically traversing from right to left, right? Then once we are reaching here, we are making right to left true, and then we will filling these values from left to right. Okay, so for that reason we are relying on this boolean variable. Now after doing this all, we would be finally having this array filled with those values. So basically those values, these are the IDs of the cell, but inside we would be filling the values either -1 or some value. Okay, so once we are done with the flatten of it, what we are doing here is I have created one queue, because we are doing the BFS bay, and this is our result variable. So initially we have pushed the cell 1, right? Because we are starting from cell 1. So I'm making cell 1 equal to true. Now see here, what we are doing is we are taking the size, whatever is the size of the queue currently. So those many number of times we are popping out the elements from it. And here we are checking that if we are reached at the destination, basically into n square, if id is n square, in that case we are reached to the target, we are returning result. Otherwise what we are doing, see here, this is our possibility, 6 possibilities for loop, right? Because we had the 6 possibility. So I'm making this for loop, and we are checking that what could be the next guy to push. So if this value, if array value is not -1, that means there is snake or ladder. In this case you can see here, if you watch here, see this 15, this node is basically having at 2 ID. So at ID 2 we have 15, that means this is a ladder, we are directly reaching to 15. So for that case, if it is not -1, then we have to reach whatever value is there at arrow 5. So at arrow 5 we have 15, right? So we are directly pushing, we are taking this value 15 and we are pushing it into. Otherwise we are taking the I. This I would be coming from these 6 possibility you can see in this for loop, right? So if it is non-negative, then we are directly going to this arrow 5. Otherwise we have to take that I. So these are our possibilities. Okay, now what will happen if it is not already visited? We are push to it, q.add, I'm adding to it and backing immediately it's true, so that we will not do duplicate many times. So we have to avoid the already visited cells. Now in this way what will happen, we are doing this 6 time for loop, and then here till the size times we are pushing these values, and once we are coming out of this size variable, we are increasing this result by 1, because that means we have one step made. Okay, because we are picking only one of these possibilities, right? One of these possibility, and here also we are checking that if it is non-negative value, then we are going to snake and ladder directly to that value. So finally, when we are coming out of this loop, we are again going to the, while queue is not empty, we will again do same thing. Whatever is the left in the queue, we will take that size and we will do it the same way, repeat it. Once we are done for all the cells, those things would be true. So we cannot no more having the values in the queue, because all of them would be popped out. So finally we are returning this result. Okay, so this result is basically returned at here or itself, that whenever we are reaching the target, that value would be sometimes would come out of this queue. If there is no possibility of it, that means we will never reach to this condition. In that case, what we will happen, we will come to this line, means we will return -1. Okay, so what is the time complexity here we are doing? We are taking the n into n. So O of n square would be the time complexity, and O of n square is the space complexity as well, because we created this array of 1 plus n square size. Okay, so let me execute this code, which I have already executed, but for the sake of video I am executing it again. Let me try to submit it. Yeah, so it is accepted 78.29%. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.